now having both customers and users module, we can now see the situation that we kind of discussed during the introduction. So there might be situations in which for the processing of some, in our case, particular command handler, we'll need to fetch the data from another module. And yeah, let's just not dive into the, I would say, possible, what could cause this situation. In many cases, that will basically maybe not bad, but inaccurate analysis. And maybe this means that you need to rethink about your module boundaries, because if something is autonomous, but at some point needs to fetch data from another module, that could be a sign that the design maybe is not perfect. But let's just throw it out. It might happen, and in many cases, especially if you have the legacy code, it's pretty hard to avoid it at some point. So let's just think about this situation, even though that we have, let's say, greenfield project. So let's modify the handler for creating the customer for now. So the current implementation is quite straightforward. We basically get the command. Based on that, we create a value object, put it into the customer, and we basically, using the repository, we store it into database. So now let's think about the following requirements. So business comes to, let's say, our department and says, okay, we have new business requirement. Before we actually create the customer, we need to make sure that the user actually exists. And what is even more, we need to make sure that it is in a specific role. We could, of course, think about other scenarios, like check whether this user has not been logged because maybe he tried to scam us for some reason, or maybe some fraud policy, which is in the separated module, detected this as some potential threat. So there are multiple, scenarios that you could come up with in this particular scenario. So, but for now, let's just think about this. So now we are in the situation in which we need to get an information about the user, which we clearly don't have in here. And we have like two, I would say, options of tackling this particular issue. So the number one would be mentioned at the very beginning, let's call this synchronous fetch from one module. And we would basically act like a call to external service. So we would like to fetch the data. And during this whole processing of this handle async method, we'll basically ask another module for the data. And the second thing that we could came up with would be slightly different approach. And we would basically flip this other way around. So some sort of inversion of control, in which once we'll create the user, our users module would inform our customer service that user has been created, and maybe you should store it on your side. So once the customer will be created, there will be no need for asking me for a specific, let's say, DTO or something else. And at first glance, it's like the second thing could be slightly better, but the issue is that it's not always that simple to determine, because everything when it comes to data consistency and stuff pretty much is not, I would say, it's not always a developer's decision, right?
Yeah, it's always a business decision whether the data can be eventually consistent or should be immediate consistent. So for example, for the medical systems, most likely you would rather fail a request than have some eventually consistent data, like giving the same patient the same, let's say, injection multiple times, because you have eventually consistent system. So it would be better if the system failed than, allowed such a terrible action to happen multiple times. But in a typical, let's say, maybe e-commerce or social media system, having eventually consistent data, like synchronizing the total amount of likes or starting your order as a classical asynchronous process, which takes time, and the user is aware that processing the order, delivery, invoicing, payment, it takes time, right? So it's natural to make this action to be eventually consistent.
And of course, I can imagine that now as you are sitting, and you might have some sort of kind of mess in your head. It's like, okay, wait, what those two guys are actually talking about? I mean, what kind of eventual consistency? I mean, we are clearly within one process, and there is no such thing as eventual consistency because I'm within the same process. Everything happens within the one, let's say, HTTP request.
There is no additional network calls between the modules. Yeah. So what consistency?
So the first thing is that it's true partially, because you will see just in a few lessons that this actually might not be the case.
Yeah.
But even though we build this modular monolith, and we not necessarily have to, but we might eventually think about the distribution, right? And we'll put this into separated microservices. And we need to, the whole idea behind creating this modular monolith is that we would like to keep this as close as the, let's say, distributed solution as possible. So we already need to think about the way that we'll communicate or integrate those two modules, because once we'll distribute them, we want to just change the implementation detail and not the strategy on propagating the information from one module to another. So if we'll distribute this, now we have the network and, the latency between, serializing this and sending from, let's say, one part of the planet to another, because that might be also the case. And then this eventual consistency, and consistency in general, might appear. Also, when you think about more technical stuff like clustering the databases, etc. So now, as Peter mentioned, you need to think, so do I really, as a business, can accept the fact that this information will be propagated from, let's say, one module to another, and this will be like, I don't know, half a second.
Or a few minutes.
Yeah.
We don't know.
Because there might be a situation in which, let's say, let's think about the integration first. So I create the user on the user's module, and user's module want to inform the customer. So I send some sort of information that we'll discuss later what this exactly will be. And let's say the customers will get this and create local equivalent of this user on the customer's side. So this is great, because we don't have, when we will create the customer, we don't need to fetch the data directly. However, if our fraud will appear, the user will turn to try to scam us, and the admin will block him, then this information needs to be propagated once again to our customer's module. And this is where this time is kind of crucial, because in meantime, once this information is being propagated and processed by the customers, the guy maybe will try to do something else. And I don't know, complete, in this particular case, maybe that's not dangerous, but thinking about some sort of transactions on the wallet, that could be dangerous for us. And once we'll introduce, instead of this model, the synchronous fetching, we have more the reliability stuff, because now we need to make sure that once I fetch this synchronously, the users, let's say, must be alive, because if this is redeployed or something else, I cannot basically fetch the data. However, if this fails, the whole process fails, and I cannot move further, and I always get the fresh data.
So to sum up, it will basically boil down to this CAP theorem, where we typically decide between the system being either AP, which means highly available, but still we have to think about network partitioning, or CP, where we prefer high consistency. So we would rather have all the nodes to be always in sync, right? To always have the same data. And we would accept that sometimes the system might fail and might be offline, not responsive, because this is more important for us to have always up-to-date data across all the nodes being synchronized all the time. And, to have this immediate consistency, then, allow some eventual consistency and maybe this actions that Darek just mentioned, which could be dangerous from the business perspective. But again, it depends on your business. And just to, emphasize this once again, it should be the business decision always, right? Whether you can allow this asynchronous operations to happen, to have this eventual data consistency or not. So let's move into our sample, and we are going to do both scenarios. The first one will be the synchronous scenario, and the second one will be this asynchronous scenario.
Yeah, we start with the synchronous scenario because it's it should be minority of your integrations. Ideally, there will be none. So we'll just see how this look like at first glance, and eventually we'll refactor this to, in this particular case, the asynchronous integration, and you will see how this might also look like.
Yeah. So let's jump into our create customer handler, and maybe let's start with just some simple, I will call it a mock, right? Let's just define the abstraction. How would we like to achieve this synchronous communication? And then we will actually implement this code behind making this communication, internal module communication. So yeah, let's do it like very similar to what you would implement in a typical, let's say, third-party service integration through HTTP, right? So we'll start with a simple abstraction. So to our core, let's just add a new directory and we'll call it clients. So as you can expect, we'll have some kind of module client. So I will just add a new interface. Let's call it user API client. So from our application layer perspective, we don't really care how it's going to be implemented internally, right? So whether this is going to be in module synchronous call in the same process, or whether this is going to be using some HTTP client, WebSocket, gRPC, whatever the protocol is, maybe this will be microservices at some point, we'll just change the implementation of this specific user API client. But from our command handler's perspective, event handler's perspective later on, we'll always operate using some abstraction. So we don't care about the internals. What's the database, what's the communication protocol, and so on.
Exactly. Yeah.
So what we will try to do here is at first, keep this user API client as internal abstraction. So we don't want to reference any kind of user's projects, because also I would say this typical approach that you might find in some modular monolith solution is that your modules would expose some kind of shared project where each module would keep some shared DTOs, messaging contracts, maybe some interfaces, and then your modules would just reference other modules' shared projects and use their public interfaces, right? So you could just inject user module client from some inflow modules user shared package. But once again, we want to keep our modules fully autonomous. We want to have no reference whatsoever between those modules. So we'll keep these local clients, local contracts. There will be no references at all. So let's start with this user API client. And this will be, of course, invoked asynchronously. So this will be, of course, returning some kind of a task. And here we'll just expect some DTO, right? Just like you would implement your DTO for custom, let's say, HTTP communication when you talk to separate web service or microservice. Let's just say that we want to have some kind of user DTO returned to us by this user's module, or maybe later on the user microservice.
Yep.
And let's call it get async. And let's just also state that we want to fetch the user by unique email. Now we need to add this DTO. So once again, typically you would put this DTO into some shared user's module project and you would reference it. But once again, we are going to keep all this stuff internal. So let's make here under our clients, the DTO. Now keep in mind that this client's DTO are just DTOs for our communication. These are not DTOs being returned by our module for the controller. So these are just internal DTOs or communication models.
This is the contract that you keep between your modules. And
exactly.
As we discussed, we don't want to make the integration via the database. We want to have something more stable, and this is the contract.
Yeah.
That's it.
So the contract will be very simple. We would expect from user's module or later on microservice that we want to get the user. So when we ask for the user by email, maybe we want to get the user identifier from this module or microservice, and then we want to get maybe a role, which we might also need for validation, as Dark mentioned, within this business process. And maybe you want some email just to verify that it's actually the same user that we asked for. So let's say this is our very minimalistic contract, right? The DTO that we are expecting from this module when we talk about the module communication.
Right.
And of course, we'll make this user API client to use this user DTO. And now, since before we actually implement any kind of user API client, class, let's just go to our handler for creating the customer, and let's inject it somewhere here. So after the repository, let's just try to inject our user API client like this. And let's just complete this application logic. So at first we can validate the email as we did before, and then we can ask for the user. So we will try to call our user API client get async. We'll provide this email, and then we can check if the user is null, then, well, the user is not found. User doesn't exist. So let's just throw some custom exception. Let's quickly make a new exception for us. Something like, let's say, user not found exception. Once again, we are going to use our base inflow exception type. And let's just provide here the email, string email. And let's provide here a meaningful message, something like user with email, and then our email value, which is the email, and then wasn't found. All right, so we are going to throw this exception here. Throw new user not found exception. All right, and the command email. Next thing is that we'll move further. Now that we are certain that the user actually exists, let's validate the role. So if user role is not user, so let's just assume that only the user with the role, actually user, is potentially a valid customer. Okay. If this would be something like, I don't know, admin, manager, let's say we are not going to allow our employees to use the app for transferring their funds, right? Let's say this is some kind of business policy. So if the user isn't the user as a role, and once again, we can either throw an exception here or just return. We can make this method or handler more idempotent, so we can throw an exception or just return, right? Doesn't matter that much. Now, let's move further. So finally, we are actually going to take the user identifier. So later on, when you look at the database, even though we have separate schemas per module, it's often quite like typical pattern that, let's say, you have the user, you have the customer, so you have a business, different entity, but since it's kind of a user with just more personal data, you might reuse the same identifier, right? As long as it fits. Or maybe you can just keep it as some external ID, so that you have some reference to this original roots of this particular entity, where it came from.
Yeah, I mean, the concepts of, I mean, that's quite, I would say, object-oriented. When you have the different behaviors and one object becomes another instead of adding crappy booleans or enums for differentiate the types. I mean, exactly. You have the object-oriented programming just for that. So this is natural, and the one that you mentioned could be either using as both for the natural key, or if sometimes in a DDD
just some reference,
it's called correlation ID, which is kind of misleading because of the technicalities that
So let's just do one last if statement, which is if this user actually exists. So if we do something like customer repository get async for the specific customer ID, and this is not now, then once again, we could just return, because maybe the user already exists for this customer. Maybe for some reason, someone called twice on this HTTP post method, and we can make it once again that idempotent call, or we could just throw an exception here, something like customer already exists exception. So we can make, let's say, a new exception like this, and let's put the customer ID. So let's say that we will make a new custom exception type. Customer already exists, actually, not just already exists exception. And let's move here. Let's make it internal and derive from our inflow exception base type once again. And let's just put the required customer ID. So simply let's state that the customer, let's make it customer ID. The message will be as simple as customer with ID, and then customer ID already exists. All right, so this is it. And now finally, let's throw this exception here. So this will be the whole application logic. As you can see, no business logic whatsoever, just some, get data from there, validate this specific property, move on, throw an exception, call database, save the user through the repository, log some data, and that's it.
Yeah, so now moving to implementation of this user API client. So as you mentioned, there are two potential ways of achieving this synchronous communication. So first, the more popular, basically because of the simplicity of this approach, is that we will have the user's module, which will expose, probably via additional assembly, some sort of public API, sorry, not the API, but rather public, maybe some sort of some sort of client, which we could use for getting the data from the module. And yeah, since it's quite simple, we won't skip it. Moreover, you've done the modular monolith stuff with this approach. So if you want to see this approach, then YouTube, your video, and quite a lot of knowledge also with this simpler approach. And here we want to make the alternative. So we will use, just like with the microservices, we'll have the local equivalents. And this is why we have the user DTO both on the user module and the customer module. So what is the issue now that's preventing us from simply calling the query on the users?
Well, since we have no reference to the users, we don't know how to call the query. I mean, I could potentially try to implement this. Let's say, let's make a derived type for this one. Let's make it an internal, let's say, sealed class. Let's try to implement this interface, but let's see what will happen. If I will, actually, let me just register it already, so I will not forget it later on. So let's just services, and then, for example, add singleton, our user API client. So theoretically, I could do something like injecting our query dispatcher here, or query handler. Or just dispatcher. Let's say like this.
Because we have one shared
IOC
container, so this is no issue.
But how am I going to call my dispatcher and then query async with get user by email? So there is this query which lives within our users module. So how am I going to call this? I mean, it's internal, but what am I going to do? Make it public and reference the user's core? Or am I going to...
then we would end up with this first approach, right?
So you have a spaghetti monolith. You have no modularity at all. Or do you just make a new user shared project where you put those queries, DTOs, like you said, and then you reference this project? But then again, this is typical approach, but there's still some reference dependency, and we want to avoid it.
And of course, you could think at first glance that quite logically you could think, wait, but you could create the equivalent of this query on the customer side and then call the handler, because the payload will be exactly the same. And this is true. However, this will fail during the runtime, because even if you would fetch some using some sort of reflection or something else, you will get the reference to this particular handler. If you try to put the object that is not exactly the one that comes from the user's module, then you would have the type mismatch exception during the runtime. And even though that you would have exactly the same payload, even the name would be the same, it's not the same type from the runtime's perspective.
Exactly.
So there is not that much that we could do without additional effort, actually.
So we need some way to actually keep our modules autonomous, to avoid all the module references, and still make it work.
So let me ask you a question. Assuming that, because this, what we are discussing right now, that I have a module, you're having the module, and we need to create a communication. So at first glance, this is now like kind of weird, and we need to think about the solution. But let's just assume that we are not talking about two modules within one monolith, but rather two separated applications that want to talk to each other. So two web services or whatever you've got. So if I would ask you how to create a communication in there, that will be no-brainer. Just do the HTTP client and fetch the data from the controller. Now, the magic that is behind this whole process is that you take the message, you serialize this to well-known standards. So in our case, probably JSON, or if you're more...
Protobuf, whatever.
Whatever. Then you basically use the transportation. So probably in our case, that would be some HTTP. and you deserialize this on the client level, on the client side.
Yeah.
To its type, right? So we could actually take the same process and apply this locally within our modular monolith. So what we'll do is the following. We, from the customer side, will basically serialize the message, and later we'll need some sort of registry that will allows us to get the type that will be within this registry. So basically, once we'll bootstrap the whole application, users module will say, okay, if you would like to call this particular query, so get user by email, then this is the type, basically type that I can give you. And so you will know to what you should basically transform your message. So once the customer would like to call our users module, we'll basically serialize this to, let's say, JSON or whatever we would like, then deserialize this to given type. So there will be no issue with basically having this on the customer side. And then we could basically call our query handler.
Yeah, whatever callback we need to call.
Just the function that will be stored also by the users, and the response will be, once again, because we will have also mismatch on the response type. So the response will be first deserialized to the JSON and deserialized to the local contract for the users. So this is exactly same process, but on the process level.
Or maybe there is no response. Maybe you just want to do something like an internal post or delete. Please delete this specific resource from this module, just like you would send HTTP delete to a separate microservice. There is no response, so you could just make a fire and forget call, fire and forget request. So yeah, the same process, just the transportation layer is actually happening in memory in the process. So we just need some very simple registry to keep that there is the list of the possible endpoints that we can call with these callbacks, and we will just call them, just like you would call typical web API.
Yeah, exactly. And of course, this pretty much depends on your needs, and we think that this approach is kinda, maybe it's not performance-wise, it's not the best,
but it's still very fast. If you make a serialization, even if it's newest system text JSON, or if you go with some binary serialization protobuf message pack, it's like extremely fast. If you have an issue with running tens of thousands of requests per second on your server, then most likely you have the infrastructure. You are scaling your app, or you already started, transitioning your app into microservices. Yeah. So if you have such issues, then it's good for your business, I guess.
Yeah. So let's just start with the infrastructure, and we'll proceed further to see how this actually fits into our solution. So I think that we can move to shared and and try to implement this. So the very first thing that we need to provide within our infrastructure is some sort of registry. So once we'll bootstrap the application, the users module can register some data. So what type do I need to provide to execute particular action, and we can store the action as well, actually the pointer to this function. And thanks to this, later we can build some sort of client that, based on, let's say, type or some other key, can look into this registry, and we can assume that this key will be the name of the message, right? So we will have this simple convention that, assuming that we have local contracts and we have, let's say, the query in the users, the same name needs to be applied also for the customers. So once again, conventions over configurations. And by using this as a key, we'll go to registry and say, oh, okay, I see that I need to serialize this to JSON, fetch this, transform to this type, and I already have also the function that I can safely call. And that's the whole point. Yeah. So let's add some sort of iModule registry.
All right. So to the infra layer, let's add a new class or a new interface maybe first. The module registry. All right. So iModule registry.
And we are giving the interface also in the infrastructure, because this will not be used in any of the modules. So this is why.
Exactly. So yeah, what do we want to put here? Some kind of list of registered actions and probably a method to register our internal endpoint and some callback, how to deal with this endpoint.
So
internally.
add some registration and get by key or something else. So
okay,
we need some sort of registration object first, right?
All right, so yeah, let's start with this registration object so we don't store it in some primitive value once again. All right, so let's call this module request registration. Okay, and here we will have the following props. So we need two types. Who is calling as who is calling whom. So the request and maybe response type.
Yeah, so expected request and
request
the
type.
response.
And then we need a response type. So let me just duplicate this value. Response type. All right, and we need the actual callback. So this will be just a func. So the delegate, it will accept or it will give us any object that we are passing. So this will be, let's say, our request. And then we have this cancellation token. So once again, this is like purely optional. We can, make use of this cancellation token within our dispatcher to cancel an asynchronous flow, but it's like purely optional. It could be even omitted. And then the final part, we will have this task which will return a response. So once again, what will be returned is just an task, so we can await it. This will be asynchronously completed, returning some object, any kind of an object. And this will be our action, our callback. And let's just make a constructor for this one like this. Let's add a missing reference. Yeah.
Yep.
So this is what our object will look like for this registration.
So back to registry itself, we can now move to those two methods, right? First will be some sort of
request registration like getting, and the other one for actually adding this request registration.
Yeah.
All right. So at first, let's make this get request registration, and we just need to provide some path, like you would provide
path or key or whatever.
Yeah, path or key, like you would provide a specific endpoint when calling web API, some unique endpoint when you are calling a separate service.
You can think about this as some sort of endpoint like we have within our controllers. So every single action that we'll have within the registration will have its unique path. And thanks to this, in the client, using the string, we could specify which registration we would like to fetch actually.
Yeah. And then we, of course, need a method to register our action. So let's call it add request action, all right, where we provide the path. And then we provide the remaining parameters. So our request type, our response type.
Yeah, we could actually pass.
Or we could pass
module request.
Yeah, let's just pass this object here, registration. All right. So now let's implement this. So we are going to implement this below because it's infrastructure ready. So we don't have to move this into any other layer. And let me just add the missing members and let's move it to separate file. All right, so do we need something here? Probably some kind of a collection to hold our registrations.
Yeah, I think that's some sort of dictionary.
Yeah, dictionary or concurrent dictionary. But in our case, dictionary should be enough. We don't need a concurrent dictionary here.
Yeah, the reason that we don't need it is that it's
always only for reading.
Yeah, the writing will be more or less sequential because we'll loop through the modules and
during startup.
So there is no
and
big
the reading, multi-threaded reading is safe.
It's thread safe,
It's safe. So let's make a dictionary for our registrations. So the key will be our path and the value will be our registration object.
Yeah.
And let's call this, let's say, request registrations. Let's make a new dictionary. We can remove this part since we are at C#9 or even higher currently. Let's start with our get, which will be very simple. We are just going call our dictionary to give us back the specific value. So from our request registrations, we'll ask for
try get value.
Yep. For our path, we'll ask for the registration. And if it's not null, we're going to return it. Otherwise, let's return null. So that's one thing. Let's make it read only actually. And the second part, we're just going to add this registration. So at first we can validate if the path is not null. So if path is null or maybe an empty string, we could just throw an exception.
Yeah. And once again, we don't need to create a known
This is like
type.
internal library, let's say. So let's just say request path cannot be now.
And yeah, and if this will fail, this will happen during the bootstrap phase.
So yeah, our application will fail. And what we need now is to just add this.
Yeah, we can also check the namespace, whether this actually is null or whether this is not empty, because if we'll generate the mentioned dynamic assemblies, then yeah, we might have an issue also in here.
For the registration?
For the what?
The namespace for the registration, right?
Oh, yeah.
Okay, so now let's make another if here. So if registration, and then we are checking the namespace of the request, or just the get type and namespace?
Yeah, this could be get type, yeah.
Like this. All right, if this is now, then once again, let's do something like
and that's
namespace cannot be null.
All right, and we can add this.
So add, and there's our path, and there's our registration.
Right. So the registry is more or less done. I think that we can already create the extensions to register our registration, and this won't be just an IOC. This will be kind of more tricky because we need to once again scan through the assemblies, look for something. Or actually, in this case, this won't be. We'll do this explicitly.
Okay.
Yeah. So we can move it further.
Okay. So should we put this into extensions or?
For now, I think we can create the extensions. For this
Okay.
So
have some extensions there already within our modules in infrastructure. So let's just make one more method there for registering our module registry. So let's make the iService collection static methods returning this iService collection, and let's just call it maybe add module request.
Yeah.
Like this. And let's put it there. So what we want to do is the following. Okay. All right, so at first, let's just register our registry, whatever it means, right?
Yeah.
So we are going to add some singletons there.
I think that for now we can just make it singleton because that's not a big deal for now.
Let's just do something like services add singleton, and then our I module registry, and register it as module registry.
Yeah.
Okay, do we need to do anything else within this?
Yeah, since the registry is completely internal, and we need some sort of way, some sort of component that in more friendly way will allows us to add the registration within each module. So we'll need some sort of public component which will be available for the modules. So during let's say use, I think that's how you call this within the I module. We could call this component and pass the path, pass the callback as a function, and this will be wrapped into this registration object and put into our registry. So some sort of component will be required for us. Okay.
So where should we? How should we call it? Should we keep it in the infrastructure as well?
Yeah. I mean, in this particular case, we need also to add this to abstractions because we need to, give the modules an opportunity to add the reference. So we can call this some sort of module subscriber or something else. Yeah.
So this will be our public interface to interact with this module registry somehow, and let's make it a Fluent API. And so let's do one method there, subscribe, and then request and response. So similar to the query handlers, but keep in mind, we can put more methods there, maybe subscribe with just a request or just a response, like a fire and forget. So we can mix these things. But let's start with this typical approach where we have a request and then we have some kind of a response. And now we are going to just provide our path, and then we are going to provide our callback. So we will have this function, so func type once again, where we provide a request, where we actually get the service provider. So we have once again our iOS container instance, and we can do pretty much anything, whatever we want to call to complete this request, we can do it for the IOC.
Yeah, because if you would basically copy the function from the registry, that's the whole point. I mean, the registry just keeps the function itself, which is already needs to be created. And now without service provider, assuming that I would need to create this, I mean, what if I have, of course I could try using new operator, but assuming that my query handler needs the, let's say, DB connection, logger and some other stuff, that would be quite hard to actually, make it manually. So we need service provider to resolve this.
Okay. And finally, the response. So we'll have, once again, the task returning some response type. And this will be our actual callback. So let's call this one action or a callback. And let's just put there some basic constraints.
Yeah, so, both should be reference types. I mean, that would be just much easier.
So where request is a class and also where response is reference type as well. Yeah. So this is the definition of our subscriber. So now we need to
implement this.
Yeah, implement this guy. So let's go into our infrastructure once again. And let's add this module subscriber implementation now. Okay, so the internal sealed class and then implementing our module subscriber. All right, let's make it a bit more visible. So through our constructor, we want to use, like you said, the registry. So we can just simply...
Yeah, we need to inject the registry.
Okay.
And we'll also need the service provider because, we need to pass it to the function.
Right. So we have these two types injected here.
So now it's no brainer. I mean, the whole thing that we need to do is actually, create the module registration object. And of course, let's start with this. I mean, we could create a var first to be more, will be much easier.
All right, so we have this add request action.
Yeah, and the second parameter is the registration. So we can first, before this line, we can create this.
Okay, so somewhere here?
Yeah, so var registration,
Okay. So the registration is a new module request registration.
Yeah, exactly.
And we need to provide our request. Right, so we simply pass our request type of.
Yeah, we have the request, I think, or not.
We have to provide it this.
So the type
the type of request, then type of response. And
now the only maybe weird thing is that we need to, now we have the mismatch on the parameters number because
there is a T and there is an object.
Yeah, exactly. So we need basically to create a lambda that will accept those two parameters, right? So the request and the cancellation token.
Exactly. So let me just make it in a separate next line.
Yeah,
so it's more clear. So we have a request. We have our cancellation token there.
Yeah.
Cancellation token. And there is our lambda. So we are simply going to...
Yeah, we need to create the scope and call the action that was passed to the subscriber because the return type is exactly the same. This is the task of the response, but the function that we store is more generic, more general. So we are upcasting to objects. So this is still no issue.
So we are going to call the handler. So we are simply going to invoke this action that we are passing.
Yeah, exactly.
And we are certain that this is a request and response, right?
I mean, it's upcasting, so it's safe.
It's upcasting, so it's fully safe. So we are just going to cast our request to the request, like this. There's our request. And then we are going to pass our service provider within the scope and this optional cancellation token. And finally, let's just include it here as registration.
Yeah.
So this is like the whole magic, right? We are just changing, let's say, from this more generic, strongly typed T request response to this, let's say, no generic, just less restrictive object and passing this lambda here.
And I would say that this is the whole magic. We can, of course, we also have to register this in our extensions. So somewhere in here.
Yeah, let's put there module subscriber. And most likely we'll need to register it using some specific approach by newing this object if we're going to use it across different modules.
I mean, the subscriber? The subscriber will be explicit. So in every single module you can explicitly. I think that we can already add this during the bootstrap phase. So if you would go to the users and to the API itself and sorry, not the, actually to the users, because the users will provide this some sort of action.
Okay, so let's open the users.
Yeah, and somewhere within the use. So use is for now.
Somewhere here we will need to make use of our subscriber.
Oh yeah, we need to add this one more thing.
So instead of like resolving the subscriber directly from the app, let's just, do
create
it
very dummy.
Do it with some more fluent API approach.
Yeah. So let's get back to extensions and add this.
So we'll make a method, simple method, returning our iModule subscriber like this, and let's just call it maybe use module request or subscribe, whatever you call it. And this will be like a purely extension method on top of our application builder, and this will do nothing else, nothing more than just returning the instance of this subscriber. So this is a singleton. So we should always get the same instance of this object with the same registry.
So let's get already, just put it in here,
Okay, so within our users module, let's just call it. So I'm going to call app use module request. So we should see this. Let me just check this one. Use module request. All right. I'll make this a public static class, and I will just make this one internal. And also this one, I'll make this internal.
Yeah.
So I can do something like use module request, and then call this subscribe, and I'm just going to provide some kind of an endpoint. So whatever, just some magic string for now. Let's say users get or users get by email.
Yeah.
Whatever convention you will follow, just be consistent with it.
So it looks like this mentioned endpoint, and we can explicitly pass the generic I mean the T request and the T response.
Right. So here we'll actually expect kind of an object which will match our get user by email. So we have this query and the query handler already in place within this users module. So we will simply expect anything which looks like this query. And as a response, let's take a look. This one returns some user details ZTO object. So this will be the response from our subscribe action.
So it's slightly closer to, I would say, ASP.NET Core routing, in which you specify this in a more fluent way rather than having the traditional controllers.
Yeah.
So the Lambda, we have the both query, which will be the T request,
there's a query,
and service provider,
and this optional cancellation token.
Yeah.
Cancellation token, which can be even discarded, but whatever. And then, well, as you can see here, we can do pretty much anything. This is our callback. So we can call any action we want. We could even ask for a repository, log some data, call web service. But since we have a query object already in place, we can just delegate it to our dispatcher, right? Yeah. So we can make it look like a one-liner, actually. So we can ask for the dispatcher simply by calling service provider, then please give me an instance of our dispatcher, and then let's just call query async and provide our query along with this optional cancellation token. So this is our callback. And as you can see, since we expect a query, you can treat it as something like HTTP GET, where you ask for the data, where you fetch data from another microservice. But you could make additional one for making maybe the user, changing the username, whatever. And you could make some fire and forget action without any response.
Actually, this one thing that actually popped out in my mind. If you would be sure that you will only rely on the either queries on commands, then you could think about simplification of this API in which within the subscribe, you would only pass the path, the request and the response, because you will always resolve the dispatcher, and based on the type, you could determine whether this is the query or whether this is the command. So I think that this could be some sort of simplification for this particular, or maybe an overload in which you could even pass less data, just those three things.
So you can make it, work with your CQRS approach and make it even much simpler.
Yeah, you can be very creative, I think.
Yeah, exactly.
So we have component responsible for adding to our registry, but we are not making the usage of that.
Yeah, not yet. Now, before we move further, let me just ensure that I am going to call this add module request. So I will register it internally. And yeah, now we can move to even more interesting part, which is how to actually make it work. So we know how to expose this internal endpoint, but how to call this endpoint, how to make a request.
So once again, let's start with the abstraction, which will be available for modules. So we'll create, I think that you already mentioned this name, so iModule client.
Okay, and this will be part of our shared abstractions.
Exactly.
You can think of it like something like iHTTP client interface, just client for communicating between your modules.
Yeah, and that's also the name is. It's not a coincidence, because now you will clearly, explicitly know that this for now is relying on the something in process, and once we'll distribute this, swap it to HTTP.
Yeah, so let's put there one method for now.
Yeah,
I will call it send async. This will give us back some kind of an expected result or response. So let's make task of the result as return type. Let's call it send async, and it will of course be of generic T result type. So here we provide our path, and then we provide a request object, just any kind of an object.
The reason that why this is object and this is not strongly typed, we don't give the exact type, is that we are going to serialize this to the JSON anyway. So and for the serializer, it doesn't really matter. So this is why this is generic, and we don't need to specify.
We can just specify that the result should be a reference type.
Yeah.
But yeah, this will be our contract, how to make use of this client. So maybe we can actually refactor our user API client already by using this approach, and then we can get back to implementation of these client details. So if we now jump back to our user API clients, we could now try to use this just to see how this is going to look like. So like very simple stuff, like very similar if you were to use HTTP client factory and HTTP client or something like this. So we are going to simply inject this module client, and then we will, make it a one-liner once again. So this could look like following: our module client, and then send async. Now we expect as the return, as a response, our user DTO. Just keep in mind that this is our internal user DTO, let's say with 3 properties or maybe 2 properties that we are going to use. User ID, role, maybe we don't even need an email, right? But from the user's module perspective, the users get user by email query, which contains this single property email, it will give us back this user details DTO, which consists of few properties like permissions, role, state, created at. But we don't care, as long as we are using any kind of flexible serialization, whether it's going to be JSON, maybe protobuf at some point, message pack. You can still, for example, just ask for a subset of the bigger object. And this is even better because from the developer's perspective, you don't have to, figure out if you, let's say there is a new guy coming to this project, this person doesn't have to figure out, so why there are 10 properties if I'm using only 2? Am I going to need them? If you don't need them, just drop them.
Yeah, exactly. So
yeah, we're going to pass our query, and we could make this query as a strongly typed class, but we can as well just use an anonymous object.
Yeah.
So we can do something like we will make a request to this user's get, and then we'll provide our email, right?
This is also why we have the object.
Yeah.
That was
so this will be, let's say, transform, serialize, and deserialize into this get user by email. There is our string property email, there is our email, so there should be a match between these 2 objects.
Just before we implement the actual client, so I think that at this point this should be quite clear what's happening. So once we have this email being passed to our send async module client stuff, so what we might expect is that we will go to the registration and use this user/get to find this proper registration. And if we could get back to users module once we invoke the subscribe. So what will actually happen is that this anonymous object is going to be serialized to what is expected on this side. So on the users module to get user by email. Since we don't give a shit about the type itself, we have the strongly type expectation in here. Then we'll call the lambda, the function that is specified in here. So this is just calling the dispatcher, and the returned object, which in this case is the user details DTO, will be returned, serialized to the something, and deserialized to what is actually expected on the caller,
which is the user DTO.
Which is the user DTO. So pretty much similar to what you have once you're working with the web services or something.
All right. So yeah, the final part.
We're missing the client.
Yeah, they're missing the client. So let's move into our infrastructure once again, the shared infrastructure. Let's add this module client implementation there. Let's make it an internal class, and let's make it implement our iModule clients. All right. So now we need to inject something through the constructor for sure. So we'll ask for our module registry.
Yeah, the registry is crucial, right? It's crucial actually.
So the module registry, and this is pretty much the only thing that we'll need. Yeah. And later on, we can also think of maybe swapping out the serialization into additional component that we could extend with.
But for now, this is it.
Yeah. So yeah, let's move into our send async. And at first, we'll see if the registration is actually in place.
Yeah, so we'll call the registry.
Yeah, so we'll see if module registry will give us back any registration object. If this is now, then most likely we want to throw an exception.
Yeah, because there will be some sort of equivalent of 404.
Not
right?
found, from the web API. Yeah. So let's throw something like invalid operation exception, our favorite exception.
I'm wondering whether there is there a not found exception?
Probably not.
By default?
No action has been defined for path. Let's be explicit of what's happening there. All right, so this is it. All right, so once we have this validation in place for the registration, let's now do this whole translation trick. So at first, we'll do something like the receiver request, and then we want to translate this request type into this expected request type. So we'll make some kind of a private helper method that will be responsible for this translation. And actually at this point, we can think of extracting maybe our serialization to some additional component. So we can exchange it to something else later on, maybe for different kind of the serialization protocol. So let's make some very basic component here, something like iModule serializer, like this.
Yeah, so we'll put this also in the shared infrastructure. So
and here we need the following methods. So let's assume that we are going to use the binary serialization anyways, just to make it a bit more faster than the string serialization. So we'll have a few helper methods. Serialize a T to the bytes collection, deserialize the T from the bytes collection, so byte value. And finally, we can have one more helper method to deserialize to any object, which will be especially useful later on. So deserialize byte values for this given type. And now let's implement this. So we'll make a new implementation, and let's start with the JSON serialization. So I will make a new, let's say, JSON module serializer. Let's move this into the separate file. So let's implement the missing members, and let's move this into the separate file. Let's make it internal, sealed once again. And let's just use our system.txt.json API, so we don't have to install Newtonsoft. Let's just use something which is more up-to-date currently. And we'll start with the basic options. So simply let's make here our read-only options for the serializer. So the JSON serializer options will be the following: new, and then we will just ensure that we don't care about this property casing. So let's just make property name case insensitive equal to be true. So we don't have to care about casing, which can be sometimes tricky, and you might forget about upper casing, so we don't care. And now the one-liners for this whole serialization and deserialization purposes. So for the serialization, we are going to use the following. We'll take our bytes from the encoding. So we can do something like encoding and then get bytes, or I think we could even do JSON serializer and then just call serialize to UTF-8 bytes, the value, and provide the serializer options. So we can do it this way. Now, the next one, which is the serialize. So again, a very simple stuff. We are just going to call our JSON serializer and then serialize to the expected T type. And then we are going to pass here our value and the JSON serializer options. So our serializer options, and that's it. We can provide here the byte value as well. We don't have to provide always a string as long as this is a valid UTF-8 string. And finally, the serialize for this specific method. So we're going to call JSON deserializer once again, JSON serializer.deserialize. Now we are going to provide our value and the expected type and the serializer options. And yeah, that's pretty much it. So now let's just register it in the IOC container so we will not forget about registering it. So here, once again, within our extension,
within the modules.
Let's register here two things, the module client and the serializer. So I module client, the module client, and our I module serializer using the module serializer. So as you can see, you can provide any serializer that you want for your module request. Now let's move back into our module client. Let me just rebuild this. And let's inject our serializer here into this iModule client. Module serializer. And now let's make this helper method. So let's just make a method here. And let's call this one translate type. So the trick is very simple, like you described. We are going to at first serialize and then deserialize, and then vice versa. So translate type to the expected type of T, being the generic method. We are going to pass here any kind of value, just some object, and then we are going to call our serializer, and then at first deserialize to this expected type of T, and then internally module serializer dot serialize our value. So this is how this inter-module translation work. It's just like in a typical web API, where you can accept any object, any JSON, for example, object or XML, and map it into your custom C# object. And the same method, the additional helper method for a translate type that we can use later on. Let's just add it here anyways. So the translation for just an object. So here we will expect a value and the type, some expected type, and then we are going to call our serializer, serialize, provide the value and the actual type. And
the type should be between the columns.
Right here.
So let's get back to the send async stuff, and let's just call our translate type method, passing the request actually. So in our case, this request will be this anonymous object that you passed along with to the client, and the actual registration request type, which is expected on the receiver. So assuming that we translated this, we are now pretty much safe to call the actual callback, or in our case that's called registration.action.
The result will be our registration, and then we are going to call this
the
action, right, our func, and we are passing the receiver request, and we are passing our optional cancellation token. And this should invoke, for example, our users module internal subscription for these users get action.
So as you can already see, this returns the object, and once again we are returning the object because we don't care from the receiver side. We don't care actually what's going to happen with this result further. We just return this, and we still need to proceed this translation back to the client, and this is why it pretty much doesn't really matter whether this will be object or it's a specific type. So now we are basically checking the result, whether this is null or not. And if this is not null, we are basically calling the translate type once again and return this to the caller.
So let's return the result. If this is null, we will return a null because, in some scenarios, you might want to have this fire and forget where you don't have a response. So this could be just some default value or null. And if it's not null, then once again, we are going to call this translate type. and we are going to translate it to this expected result, the result, and provide our result returned by this, let's say, users module in that case, in our scenario. So I think we have all the pieces in place, and now it's high time to actually see if it works, right?
Yeah, exactly. So we need to actually call our create customer handler, see how the abstraction is calling actual implementation built on top of the iModule client, and hopefully we'll see that this registration will be fetched from the client, and the types will be translated.
So I'm just going to put a few breakpoints here and there.
Yeah.
And let's start the app, and let's try to invoke our create customer handler, and let's see what happens.
Yeah, at this point we don't even care whether the user is actually there, because the callback will be invoked anyway. So it's just a matter of the payload.
Exactly. So at first we are registering from the user's module perspective.
Yep.
So let me just add this request action. So there's this registration going on. So we have single registration for this endpoint. But now let's create a user actually. So just make it work. So I'm going to go to this user request, and let's say user free. We have user 2 somewhere already. So let's make user free. Let's sign up. And now let's go to the customers, and let's see within our create customer module that after the email validation, we will just go with this user API client get async. So let me put a few breakpoints also here. And let's call this create customer for this user free inflow.io. So here is what will happen. We are going now to call this user API client, which will internally call this module client. So let's proceed. So we are calling our module client. Now we are looking for this specific registration for this users get. And as you can see within our registry, we have this single registration in dictionary. So this should not be null. Now we are going to call, or actually at first we are going, call the translation. So we are going to translate this anonymous object being passed from the customer's module to the users.
Known for the users.
Yeah, so it should work. Let's see. Receiver request has been properly transformed, and I can see.
Can you do on the dialog below? Can you do receiver request dot get type?
Yeah, and let's do evaluate expression and then get type. Yeah. And as you can see, this is the expected inflow modules users get user by email type, and the value is there, so it's been properly transformed.
Yeah. Now we are calling the actual
callback.
Yeah.
So this will hit the internal breakpoint. So it will make a scope within our service provider, and it will call the action. And the action will actually call our users module subscription. Yeah. So this will call our service provider, and this will call this internal iDispatcher. And if I put a breakpoint within our handler, you will see that we are, of course, going to call eventually this endpoint. We have the user fetched from the database. There is the user. We are going to map this user to this user DTO. And this is the user details DTO from the users module. So this will be returned. And now, since this is a user details, once again, as you can see, this is when I call get type coming from the users module, right? This users DTO object. So we need to translate it back to the expected result from our customer's module perspective. So the expected result is of user DTO, the customer's module. So let's transform this, and there is our user DTO, which is now, of course, if I evaluate this expression once again, the local contract, local DTO defined within our customer's module. So this is this whole magic. And now we just proceed with the whole flow. There is our user role, everything is valid. We create a customer, we add this to database, and within our users module, as you can see, we have the user in this database, in this users table, and within our customers module, we have the latest up-to-date customer enriched with some additional data at some point later on based on this user free with the same identifier as here. So we have these additional properties that we are going to use to just complete our account, verify the customer, and so on and so on. So that's it about the synchronous communication part, I see. And just to emphasize once again, we are using the abstraction. So if we were to transition to microservices, we'll just refactor this into, for example, iHTTP client factory instead.
Yeah, and I think that once we got to some sort of summary, let's just briefly discuss the pros and cons of this particular approach. So pros are partially discussed already. So we have this truly autonomous modules that basically don't know about the existence of the other modules because we don't depend on any shared packages, and that is, for me, that's gold, pure gold. And speaking about the even the testability, the isolation of the modules, it's really clear where my module actually ends up, where's the actual boundary. So this is great. However, of course, with great power comes also the responsibility, and now it's kind of clear, and partially we could see this once you discuss the user DTO, that now we might have the situation in which user DTO, let's say, on the customer side may be different than the DTO on the user's module. And of course, if this is the subset, then that is great, because for me, if I'm not using some particular properties, I don't want to have it in my module. However, what will happen if
they change
someone
existing property type, for example?
So the either type or even the name,
or they remove the property and it's null now.
So basically, if we would have the shared packages, this would break the code immediately during the compilation process. While in here, because we are relying on the contract that we believe that won't be broken at some point, this will still work during the compilation process itself and will break during the runtime. So the long story short is, if you have this approach, then you need to be either very careful, or the second option would be very careful and add some sort of testing on top of your contracts to make sure that they are more or less consistent. Because if they are not, then your code is gonna fail at some point.
Yeah. So you could either use something which is very, I would say, common or very popular in microservices world, which would be the packed testing library.
Consumer contract driven testing,
Or you can use something on your own. For example, in .NET, you could implement some reflection code, whether this would be validated during your application runtime or within the unit test. You could just have some reflection code comparing two types, which are, of course, which should be the same, by, through reflection, going through their methods, properties, validating if it's the same property name and same type, and you would get the results. Even better than using packed, because you could, for example, state that this should be decimal or this should be float, while for the packed, which is JSON behind the scenes, this is not that obvious. So you have to be both careful, and ideally you should also have some kind of test or validation for your contracts.
But honestly, I'm not quite sure whether, the consumer contract driven tests are, this another type of test that you need to introduce to your application. And I know that at some point this might be kind of overwhelming, that, okay, these guys are doing the application, but they are doing the module loader, and then now they are introducing some sort of module clients, module registry, and a lot of infrastructure, and they are also are talking about some sort of consumer contract driven testing. So this is way too much for the monolith. However, if you have somewhere back on your head this, that this distribution of your system may appear at some point, then I would say that this is also a good thing that you're already feeling this pain, because once you will distribute your system, this is gonna be part of your life.
Yeah.
Because since you have no physical, you have the physical boundaries of each individual microservice. There is no shared file system. You need to test the consistency of your contracts that you're relying on, because there is the only thing that actually is using for the transportation and the integration between your microservices. So if you are slowly pointing to the microservices, you can start adopting the techniques and, let's say, the ethos of working with those problems, and try to thinking about some sort of process to tackle it. And once you will eventually move to microservices, this will be basically no-brainer for you anymore.
Yeah.
And you can focus on other stuff that will kick you definitely.
Yeah, but even without microservices, this is actually the only way to make your modules fully autonomous, to make them fully independent.
Yeah.
If you start sharing your types, you might end up in a situation where, let's say you have 10 modules, and then let's say multiple modules will be adding references to other modules. Then someone will, change something. The code will not compile anymore. Maybe because someone removed the property, which is still not used within your module. This should be ignored, or this is an obsolete property, but still the code could break. And, then when you actually distribute it into microservices, you might think of creating some shared NuGet packages for your contracts, and then you might end up in some versioning hell for your contracts. So there are both pros and cons to both approaches.
Yeah.
But from this perspective of having like fully independent modules, this is pretty much the only choice.
And one thing that I think it's worth mentioning is that, even though there's quite a lot of code that needs to be written, if you, at some point, once you'll finish your first modular monolith project, once you finish it, you can extract most of this infrastructure to some sort of nugget, or even create the .NET CLI template. Mm-hmm. And each new greenfield project that will be starting as a modular monolith will be generated with not much effort. The whole infrastructure will be already waiting for you, and the only thing that you need to pay attention now is to do your homework during the analysis and create the modules and be focused on the actual business values. So I wouldn't say or you can basically go to GitHub, clone the repo, or you created the...
Yeah, we have the existing modular framework repo in our GitHub, so you can just clone it and use it as your template, use the parts that you need, remove the other parts, or add some custom parts. So you can just reuse it. You don't have to implement it on your own anyway.
Yeah, but the whole purpose of this is basically to understand the concept behind this, and so you can adjust it to your needs, and at some point maybe modify so this will suit your needs most.
Yeah. So this is all about this quite long communication part, and now we are going to move into the integration part, where we are going to change our approach from this direct end-to-end synchronous calls to this asynchronous event-driven notification style.
Yeah, so basically inversion of control on the system level, I would say.
Yeah, so we are actually going to use what we already implemented. This whole module registry and client will be used again with some additional extensions, but I would say most of the important pieces of infrastructure we have already implemented, and we are just going to follow mostly the similar concepts and just apply this event-driven architecture idea.
So next lesson will be just an hour long.